Hi, my name is Adam. Welcome back to Godot Game Lab. In this video, we'll add a bunch of new features connected to the Battle Rewards. First of all, you can see that we have a GoldUI here, showing us that we have 70 starting gold. What we can do is we can go to a battle and actually try to win that battle. What you can also see is we are introducing some new cards, and we have this little diamond-shaped thingy here, which sort of represents the rarity of that card. We have common cards with gray, uncommon cards with blue, and rare cards with gold. So after actually successfully winning a battle, we can click on this awesome button, and we are no longer greeted with that placeholder reward screen we had before, but we have an actually working reward screen. And if I click on the gold, you can see that it gets added to my current gold, and we can click on this add new card button here, and we get offered 3 random cards. We can see what they do, and we can also decide to take, or we can decide to skip that reward altogether. For now, I'll take this blue one. You can see that the battle rewards are empty now, and if I click on continue, we go back to the map. So the gameplay logic and flow is still there, and you can see that my deck is consisting of 13 cards now, and if I click on it, indeed there's a new card at the end here, which I took from the rewards. So let's get started. Before we jump into implementation, however, let's talk architecture first. From a data perspective, we need a bunch of changes. First of all, we need to introduce card rarities for our card resource. We'll have common, uncommon, and rare cards. Why do we need this? Well, because cards with different rarities have different chances of appearing as rewards, just like in Slay the Spire. We also need to add a new card pile property to our character stats, which I call draftable cards. Why? The reason is simple. In Slay the Spire, you can't get starting cards as rewards, right? In order to exclude strike and defend cards, we create a separate array of cards which can appear as rewards. Lastly, we'll also need a brand new resource called RunStats, which we use to store 2 things: the current gold the player has, and the chances for the different cards to appear as rewards based on their rarity. For this, we use a weight-based system like we used for enemy actions in Season 1. Now let's zoom out a bit and see how the Battle Rewards architecture will work. First of all, we'll have 2 dependencies from the outside world. Data we need, right? One is the character stats resource, and one is a RunStats resource. Why do we need the character stats? Well, first of all, to generate card rewards, we'll need to have access to the draftable cards array for that specific character. And also, when we actually draft a new card, we need to add it to the deck, right? As for the RunStats itself, we need to have access to the current gold, so we can add gold when we click on the gold reward button. And also, we need to have access to the weights for the cards to appear by their rarity. Then, the battle reward itself does its thing, and the only communication it provides to the outside world is the battle reward exited signal, for which we use the event bus. And then the run itself can connect to that battle reward exited signal, so we can go back to the map when we're finished taking our rewards. And that's all from the architecture side. I hope it's not that complicated, so why don't we go ahead and start implementing it. And the first thing we'll do here is implementing card rarity for our cards. So I have my project open here, and I go to the script tab, press Ctrl-Alt-O, and search for card.gd and open up that script. And the change we'll make here is not that big actually. First of all, we'll need a new enum for the rarity with the values common, uncommon, and rare. Then we'll also have a new constant with a dictionary called rarity colors, where the keys will be the rarities themselves, and we assign a color to them, which we can use to modulate that little diamond texture we'll have for the cards. For the common, I used the gray color. For the uncommon, I used cornflower blue. And for the rare, I use the gold here, but feel free to use any colors you like. And then the final thing we need is under card attributes, we'll add a new export variable, which we'll call rarity, and assign that new rarity enum type to this. And from a code perspective, that's it. So why don't we save this with Ctrl-S and move forward. So for this rarity to be actually useful, we need to visually indicate it to the player, right? Where do we need to do this? If you think about it, we have 2 scenes where we display cards for different purposes. We have the CardUI.tscn and we have the CardMenuUI.tscn scenes. So let's go back to 2D view, and we can close all the other scenes by right-clicking this one and saying close all tabs. And we can press Ctrl-Shift-O and search for CardUI.tscn. press Ctrl-Shift-O again, and search for CardMenuUI.tscn. Okay, so we have these two scenes here, right? Let me zoom in on this one for a second. So we have this one, which we use to actually play cards, and we have this one, which we use in the CardPileView, for example, or in other menu places. And we have a problem here, right? We have sort of repeated ourselves, if you think about it, because we have code to display or override these values, this panel, this cost, this icon. And we have the same thing here. Even though it's under a control node, the purpose is the same, right? We have some pieces of code to change these based on the export variable we have for that card. And that's a problem, because every time we want to change the appearance of those cards, we have to do it twice in two different places. And that's what we call a code smell, right? Because you know there's something wrong, and that's not something you want to do, right? Because it's really error prone. What happens if I do it in one, but I forget to do it in the other one? Your code and your project can very quickly become inconsistent. So how do we solve this? Well, if you think about it, the visuals themselves are the same in both cases, right? We need to set the panel, set the cost to the mana cost, set the icon, and we'll introduce this new rarity thing. So what we could do to refactor this is sort of take this visuals node here and make it its own scene. Call it CardVisuals or something like that. And we can instantiate that visuals for the CardMenuUI and for the CardUI too, because they share the same functionality, they share the same purpose, right? They just want to display a card based on the data. So that's what we'll do. And I did this on purpose so I can show you how refactoring works when you have a bigger project, right? Because a lot of things can go wrong. And this is usually referred to as technical debt. So if you have to change something later on in the project, it usually becomes harder and harder and takes more and more time to change something, right? But I want to show you that the project is set up in a way that it's not that bad. We can do it pretty quickly. So what do we need to do? We're in the CardMenuUI scene, and this will be a better sort of starting point because we already have this control node and we can save this whole thing as a branch. But first, before we do that, let's not forget that we need to actually add something to represent the rarity of the card. So with this visual node, control node selected, click on this plus sign or Ctrl A to add a new child node, and we'll add a texture rect to this. Double click and rename this to Rarity. And we can set up a bunch of stuff here. Set the expand mode to ignore size, scale to keep aspect centered, and under layout and transform, we can set this to 6 by 6 maybe. And under the anchor preset, we can set it to the top right corner. And after that, we can go into move mode by pressing W and move it around a bit. Somewhere here looks fine. Go back to select mode, go to the texture property, click on load. And from the art folder, we have this little diamond here for the rarity. So double click this. And you can see that we have our rarity here. And what we'll do is we'll change the modulate property based on the rarity of the card. This is why it's white by default, because we can set it to any color we want with the modulate property. Right. So under this visual node, we have all the things we need, right? And in order to make this reusable, what we do is we right click on this one and go to save branches scene. And under scenes and UI, we can save this as CardVisuals.tscn. And you can see that it collapses and it sort of becomes its own node. So if we click on that little open in editor icon here, you can see that we have our CardVisuals node. And if I zoom in, we have all the stuff we need. We can double click the root node, however, and rename it to CardVisuals, save this scene. And we also need to attach a new script to this because this CardVisuals want to handle all the functionality related to changing all the stuff inside. So what we do is we click on this attach script button here. CardVisuals.gd is perfect. And we can use the empty object template so we don't have any auto-generated code and press create. So how this new CardVisuals script will look like? Well, first of all, we'll provide a new class name for it called CardVisuals. Then we'll have an export variable for the card property, which will have its own setter function called setCard. We'll have 4 already variable references to the panel, the cost label, the icon texture, and the rarity texture, which we just added. And we only need to really provide this setter function here, which will start with checking if the node is ready or not, because export variables can be set before the node is ready in the scene tree when we run the project. And if it's not ready, we just wait for the ready signal, and then we'll update a bunch of stuff. We set the card properties value to this new value we have. We update the cost, the texture, and the modulate property of that rarity texture rect we have. And sometimes I encounter this error message in Godot. As you can see, it says cannot find member rarity colors in base card. But if we click on the card class with Control click, you can see that we have this constant here. So what's going on? If I go back to the other script, the error is still there. And I found that sometimes this enum, it's like it doesn't get registered for some reason. So what I do in this case is press Ctrl S to save everything and go to project, reload current project, save all scenes. And when the project gets reloaded, this error message sort of disappears. So this new enum gets registered. That's just a minor bug, which you have to deal with sometimes. But don't worry, the code is perfectly fine. So why don't we test this, right? To see if it works or not with all this new code added. So let's go back to 2D view. And you can see that with the CardVisuals node selected, we have this new card property here. And under the cards folder from the warrior class, we can pick any of those cards. I'll use the slash here and drag and drop it as a card. And why don't we just double click it and change the rarity from common to uncommon to see if the changes work or not. So save this scene, run it with clicking on this icon or pressing F6. And you can see that it indeed updates everything. The cost is 2, the icon is this one, and we have this little blue diamond here indicating that it's an uncommon card. Cool. So that's all we need from this visuals scene. If we close this, we can set this back to common for the slash and save it. Okay, so what's next? We have this little change here using that reusable CardVisuals scene, but we need to make sure that the CardUI and the CardMenuUI still works. So let's close this scene for now. We immediately have a problem here because this visuals node we had before had these signals connected to the CardMenuUI's script. So if I click on the script for the CardMenuUI, you can see that we have 3 callback functions here. The visuals GUI input, visuals mouse entered, and visuals mouse exited callbacks. But there are no signals connected because the signal icon is not appearing here, right? So we definitely need to fix this first. So to do so, just select the visuals node, go to the node tab, make sure you're in signals, and double click those. So GUI input on visuals GUI input is fine, connected. We already have the function, and this green icon should appear next to it, indicating that it's connected to a signal. And we do the same for the mouse entered, double click this and connect, and the mouse exited signals, double click this and connect. So those broken signals are fixed now. Save this with Ctrl S. And we also need to change this setter function, right? Because when we set the card value for the card menu UI itself, we no longer have properties like cost, icon, and so on, because those are all under this new visuals scene, right? So we can delete these, and we actually need to scroll all the way back up because our onReady variables are also kind of broken. They reference existing nodes, but we don't really need access to any of those nodes inside the visuals node because the CardVisuals scene takes care of all the things we need itself. So we can delete all of these, and instead what we can do is we can click on this visuals node here, click and drag it, and press Ctrl, release the mouse, and we have a new onReady reference to our CardVisuals node, right? Just to be consistent, I can fix the new lines here. And you see that we have error messages, right? Because on the mouse entered callback, we want to set the panel's theme override style box, and the same for the mouse exited. But we no longer have access to a panel property, right? But what we do have is visuals.panel. Right? Because we have the same stuff under our CardVisuals scene. So all we need to do is change this to visuals.panel. Again, because if I open this scene up in the editor, you can see that we have all of these, right? And we reference them as onReady variables. So when I type visuals.panel, this means that this CardVisuals panel property will be accessed. So these are fixed. And also under the setter function, when we set the card on the card menu UI itself to a new one, we also need to make sure to pass this on to the CardVisuals scene. So what we'll do here is we'll type visuals card equals card. And with this, we actually pass the new card to the CardVisuals scene too, so we can update all the things we need. Cool. So the CardMenuUI should be fixed. Save this with Control S, and let's see if we can test it. So we should be able to test it in isolation too, right? So if we go back and select our CardMenuUI scene here, go back to 2D view, in the Inspector tab, select the CardMenuUI itself, and we should have a card assigned to this. If you don't have one, you can always drag and drop one from here, but we have the blocking card assigned in the inspector. So if I run this scene with F6, we should have this block card, and I can still hover over it. The panel updates accordingly. We have the rarity set as uncommon, the icon and the cost updates too. So the CardMenuUI works just like it did before. Perfect. So next up we have the CardUI. So let's go over to the CardUI scene and zoom in a bit to see what's going on better. And you can see that we have our panel, cost, and icon here. And that's why we started the refactoring in the first place, right? Because if we kept our old solution, we would have need to add the Rarity texture here and also change the code and make it work twice, basically. And we don't want to do that. So instead, what we'll do is we select these 3 nodes and delete them. Select the CardUI, the root node, and instantiate a new CardVisuals scene, right? Which we did just before. And you can see that we have everything back, right? Just so we keep things organized, we can drag and drop this all the way to the top to make sure it's the first node here. And there's one thing you need to be really mindful here. You can see that we have this signal icon here for the CardUI. So let's select it and go to the node tab. You can see that we have the GUI input, the onMouse entered, and the onMouse exited callbacks connected to the root node, right? The very top. So we need to make sure that we can't click on the CardVisuals itself. We need to make sure it ignores all the mouse input and mouse events, because then the CardUI itself wouldn't be able to access those events. And we don't want to refactor that because there's no reason, right? It's fine that it's connected to the root node. We just need to make sure that the CardVisuals node can't hijack those events, basically. So what we do is we select this CardVisuals node, go back to the Inspector tab, and under Mouse, set the filter from Stop to Ignore, right? So this way, this CardVisuals node can't pick up any mouse input events, but the CardUI still can. And this is what we want because those signals are connected to the CardUI. Cool. From the editor side, there's nothing else we need to change. That's it. So save this with Control S and click on the script for the CardUI. And let's see what we need to change here. Well, first of all, we have 3 already variable references which no longer exist, right? There's no panel, cost label, and icon directly under the CardUI anymore. So what we do instead is we set up an already reference variable to this CardVisuals node we just instantiated, right? So if we scroll down a bit, you can see that we have some error messages here and we need to fix them. So under the setter function where we set the card to a new value, we no longer need to update the cost and the icon, right? Because we don't have access to them anyway. What we need to do is very similar to what we did in the CardMenuUI, saying that CardVisuals.card should be equal to our new card we have here. And the setter function in the CardVisuals class itself will take care of updating all the visuals. On top of that, we also need to fix this setPlayable function here, because when the card's not playable, we want to add this red font color override. And also we have this modulation change to the icon to make it semi-transparent when we can't play a card. So we don't have cost as a variable, right? It's not declared in the current scope. But what we do have is CardVisuals.cost, right? Because we have those same property names under CardVisuals. So what we do is we copy this CardVisuals dot and we fix those references. Cool. No more error messages, right? Everything looks fine and dandy. We can save this with Control S. And the next logical step is to test it, right? So we can kind of do the same thing we did with the CardMenuUI. Go back to 2D view, select the CardUI, the root node, and we could assign stats here, but we can actually test this in game too, right? So why don't we go ahead and open the run scene with Ctrl-Shift-O, searching for the run, and starting a new run by pressing F6 or clicking Run Current Scene. Right, so we have our map here, we have the deck. Let's see what we can do. So if I click on the deck, looks like the CardMenuUI works in context too. I can click on these cards, we have the rarities there. I can click on them again to close it. So this works fine. Let's see if we go to battle. Oh, I immediately hit an error message. What happens here? Let's try to interpret what's happening here. Invalid index panel on base CardUI. If you take a look at the file, we're in cardBaseState.gd. And what happens here is when we enter the base state, we set the CardUI's panel to the base style box, right? To make sure it resets from either the hovering style box or from the dragging style box. But the problem is we no longer have this panel property here, right? So we need to fix this not just in the CardUI class itself, but let's not forget that we have a state machine attached to it. And in that state machine, all of those card states have access to our CardUI class so they can change the appearance, just like here. So let's stop the game for a second and see how we can fix this fast. Because that's the problem with refactoring, right? When you make changes like this, you always need to be aware that it might have unforeseen consequences. It's not that big a deal in this case. All we need to do is press Ctrl-Shift-F so we can find in files and we can search for CardUI. And click on find and we can sort of move this up so we'll see all the results for this. And we need to think about these results for a second. From all the results, which are the interesting ones for us? Well, we had 3 already variable references we got rid of, right? CardUI.panel, CardUI.cost, and CardUI.icon. So we should be looking for those. So if you take a look at this, we have a CardUI.panel here. So this is a broken reference, right? So if I click on this, it opens up the script, and you can see that we're in cardDraggingState.gd. And indeed, when we start dragging, we want to set the panel to this drag style box. So what we do is we correct this by typing CardUI.CardVisuals.panel.set, right? Because we have this CardVisuals under it. And with this change, we can set it directly here. So let's copy this so it's easier to fix it everywhere. And if we go back to the results, I scroll down and we have another one in this file. If I click on this, oh wait, it's not another one. It's the same CardUI, the same line. So this is fixed. We can scroll down. And we have another one here. So if I click on this one, this should be the base state, right? Yes, it is. So we can click on this, paste this CardVisuals dot, and this should be fixed. Let's see, do we have anything else? Yes, we do for the hover state. So let's click on this one. Yeah, it's the on mouse entered signal in the base state itself. So we can fix this again by inserting this little addition here. And we also have the on mouse exited in the same file, the cardBaseState.gd. And we can fix this one too. If I scroll down, that should be it, right? So if we refresh this and drag it all the way up so we can see what's going on better, we actually see the same thing. Why is that? Well, because we haven't saved our scripts. So let's not forget to press Ctrl-S to save them and refresh it again. And you can see that where we had CardUI.panel, this is CardUI.CardVisuals.panel. So this one should be fixed. And we can double check by scrolling down and looking for culprits, but we don't really have any broken references anymore, I think. But we always need to test it, right? So we can click on this search results button here to close it. And we can run the current scene again to see if it works or not. So again, I can click on my deck cards here. So the CardMenuUI works perfectly fine. If we go to battle, okay, the game no longer crashes. I can drag the cards, right click, release them. Everything looks like it's working. When we don't have the mana to play a card, it goes red and the icon becomes semi-transparent. I can end my turn and the game plays just fine. We can just double check the discard and the draw piles, but they should work perfectly fine too. And they do. So we fixed everything and sort of got rid of a code smell, which is pretty neat because if we want to change anything related to the card's visuals now, we only have to do it in one place. And all of our code base is still the same. Everything still works. We just needed to fix a couple of broken references and that's it. I hope you learned something from this refactoring stuff, but let's move on to actually implementing the new things now. So the final thing we need to do regarding card rarities is actually adding some new cards to test them out later on when we implement the card drafting stuff. So in order to do so, let's go back to 2D view, and under the Warriors cards folder, we can create some new cards. So right click on the cards folder, create new, and we can create the script first. For the template, we'll use card logic, and the name of the script can be warrior_big slam. This is what we'll call the first one. And with the script ready, we can again right click, create a new resource, this time a card resource. We can call this the same, warrior_big slam. Save this, double click the resource, assign the script first, so we don't have to assign the icon twice. And we can sort of expand these groups here. The ID will be the same, warrior_big slam. This will be an attack. It can be uncommon. We can target a single enemy with this. It will cost 2 mana. For the icon, we can load something from the art folder. Maybe this hammer here. For the sound, we'll quick load a new sound. And we can use this /sound here. And for the tooltip text, use whatever BB code you like or whatever you want the card to do. I just wrote deals 10 damage and apply to exposed. And exposed will be a status effect we'll implement in a later video. So that's all we need for the Warrior Big Slam. We can save this with Ctrl S and do another one. So right click the cards folder, create a new script. We'll call this Warrior True Strength. And again, this will be a card logic script. So we can create this, right click the cards folder again, create a new resource, card.gd is fine. And we'll call this Warrior True Strength again. Save this, and if we scroll down, it should be here. Double click the resource, assign the script first, expand the groups. The ID will be the same, Warrior True Strength. This will be a power card, and this will be a rare card too. Self-target is perfect. The cost will be 3. For the icon, we can load something from the art folder. I will use this small red potion here. For the sound, we can quick load the true strength.ogg. And for the tooltip text, again, use whatever you like. Mine just says at the start of your turn, gain 2 muscle, because this will be again related to status effects, modifiers, and all that cool stuff we add to our battles later on. Cool. So let's just save this with Ctrl S, and also need to change those scripts a bit so they print out their message or do their thing. So double click this warrior true strength.gd. And for this one, we'll just override the defaults here, and it will be super simple, right? In the apply effects function, we do nothing but print out a debug print message that says this will apply cool status to our character. That's all we need for now. And we can press Ctrl-Alt-O and search for bigslam.gd. And here we can actually do something because we can easily do the deal 10 damage part now, right? So what we do is we create a new damage effect in the apply effects method. We set the amount to 10, set the sound, and execute it, right? And we'll also have a debug print message here saying that this will also apply a status effect later on. Cool, so we can save those with Ctrl S. And finally, we're done with card rarities and test data, so we can move on to our next topic. But before we actually do that, let's test this, right? Because we haven't tested those cards yet. So we go back to 2D view, search for the Warriors starting deck resource, double click this, expand the array, and add 2 new cards to this, and drag the Big Slam, and drag a True Strength card too. So now if we go ahead and start the run, we should have 12 cards in our deck. You can see that the icons and the rarities are working. We also have the tooltips working as well. And we can go into battle. And let's see if we can draw those cards. Yeah, so this should deal 10 damage, and it does. And it also has this debug print message that says this will also apply a status effect later on. Cool. So now what we can do is we can redraw the power card. See the tooltip, it's working. And if we drag and drop this, you can see that we lost 3 mana. And we have that this will apply a cool status to our character message, which is perfect. So everything's working fine. And we can really move on to our next topic, which is adding gold to this equation. So we need to add gold to our game. If you remember the architecture discussion from the beginning of the video, we were talking about creating a new resource where we can store the gold, and we call that resource RunStats. So why don't we go ahead and create the code for that resource? To do so, let's go to the file system. We can collapse the characters for now, and under custom resources, we can right click, create new, script. We can call this RunStats.gd, and we can use an object empty template and make sure it inherits not from the node class, but from the resource class. Create the script and double click runstats.gd to open it up in the editor. And this resource is pretty simple, especially when we only deal with gold. So what we do is we create a custom class name. We'll call this RunStats. Then we'll have a signal when the gold value changes. We'll also have a constant, which we can call starting gold, and we set it to 70 for now. We'll also have an export variable called gold, which we set equal to the starting gold and also provide a setter function for. And the setter function, what it does is it assigns the new amount to the gold property and emits this gold changed signal. And that's all we need, really, from this resource. So we can save this with Ctrl S. And with our RunStats ready to go, we need to actually create a UI scene for displaying the current gold we have in the top bar. So let's go back to 2D view and click on this plus sign to create a new scene. And we use another node as a root node here, namely an HBox container. And if we zoom in to see what's going on better, we can add 2 new children to this with this plus sign or pressing Ctrl A. The first will be a texture rect. And select the HBox container again and add a new child node and this time a label. Right, so we can change the names first. So double click the HBox container and rename this to GoldUI. We can double click the texture rect, rename it to icon. And I think the label node can stay label. Right, so for the icon, we need to load the texture, which will be in this art folder, and we have gold.png here. And you can see that it's really messed up right now, but we need to set the expand mode to ignore size and the stretch mode to keep aspect centered. And under layout, we can set a custom minimum size of 8 by 8 pixels, and you can see that it looks a lot better. For the label, we can type in something like 9999 to see how it looks like. We can align it vertically on the center, and under layout and container sizing, we can set its vertical stretch mode to fill, like so. Okay, that looks all right, but the GoldUI HBox container itself is pretty tall. So what we do is we go to layout, and transform, and click on this arrow to reset those properties. That looks much better. And we can also go to container sizing and make sure that this container itself will shrink to the center of its parent, because this will be under another HBox container in the top bar. Cool, what else do we need? We need to set the separation between those, because it's a little too big for my liking here. So we can scroll all the way down to theme overrides, constants, and we can set a separation of 2, for example. Yeah, I think that looks much better. And from the editor side, I think that's all we need to do for this scene. So why don't we save this with Ctrl S, and we can go back to the root folder, go under scenes, UI, and we can say this is GoldUI.tscn. And of course, we need to attach a script to it to make sure it works. So why don't we do just that? Click on this attach script button, and GoldUI.gd with object empty is perfectly fine. Press create, and let's get coding. Yet again, we have our hands on a pretty simple class. So what we do is we provide a custom class name. We call this GoldUI, and we'll have an export variable for a RunStats resource so we can have access to that gold. And we'll also provide a setter function for it. We'll also have an onReady variable reference to our label node. And in the ready function, what I did is I set the labels text to 0, so it doesn't stay in 9999, but you can leave it at that as well. It doesn't really matter. What matters is providing the setter function for the RunStats property. And what we do is we set the RunStats to this new value and check if the gold changed signal is already connected to our method or not. And if it's not connected yet, then we connect this update gold method to that signal. And we also call it once to make sure that we initialize it to change it from 9999 to the proper amount. So the last thing we need is this update gold method, and it's pretty simple. What we do is we set the labels text property to the RunStats gold property and convert it to a string to make sure that we can set it. And that's all. We can save this with Control S. So we could test this with the RunStats export variable here, but I think we can test it in the run itself. It doesn't really matter. So why don't we change the run next so we can actually see this GoldUI scene in action. And to do so, let's go back to the run scene, go back to 2D view. And what we need to do is we have this top bar canvas item here, and we have an HBox container, which we call bar items. And if we expand this, we have a placeholder control node here and the deck button, right? So under this HBox container, we can instantiate a child scene with Ctrl-Shift-A or with this button, and we'll use a GoldUI here. And you can see that it works, but it's at the end because the order of the nodes matter. So if we drag and drop this to the first place, we'll have this GoldUI here. And we can right-click on this and click on Access as Unique Name to make it scene unique, to make sure we can access it from code. And that's all the setup really we need from the editor. And now we need to hook this up with our run script. So click on the script icon next to our run node, and let's see what we need to change here. Okay, so we have our run class here, and hooking this GoldUI up will be pretty simple. We need to do a couple of things. First of all, we'll need a new onReady variable reference to our GoldUI itself. Then we also need a variable where we can store our RunStats throughout the whole run, which I just called stats here. So where do we create this new resource? Do we do it in a file system or do we do it here in code? For testing purposes, it doesn't really matter now. We need to revisit this anyways when we implement our save load system at the very end of this course. So for now, we'll just create this RunStats resource from code, which is pretty simple. In the start run method, before setting up the event connections in the top bar, we'll just say that our stats will be equal to a new RunStats resource. And here at the end, I also included some testing code. And what we do is we create a timer in the scene tree, which lasts for 3 seconds. And when it times out, we add 55 gold to our stats to make sure we can check if the GoldUI updates accordingly or not. And the final thing we need to do is in our setup top bar method, we'll assign the stats variable to our GoldUI's RunStats export variable to make sure that it has access to this new resource we create from code. And that's all we need here. So we can save this with Control S. And with the run scene selected, we can easily test this by running the scene with F6 or with this button. And you can see that we have 70 gold by default. And after 3 seconds, it goes to 125. Which is perfect because for the starting gold, we've set 70, and we said that after 3 seconds, we should add 55 to that, right? So everything works perfectly, and we're basically done with this GoldUI and gold functionality. Before moving on to the BattleRewards though, let's not forget to delete the temporary code which we just wrote to check if the GoldUI is working or not. So let's scroll all the way up to the start run method here and delete these 2 lines. Press Ctrl S to save. And we can actually start doing the BattleRewards next, but we can immediately expand upon our RunStats resource. So press Ctrl-Alt-O and search for runstats.gd. Let me show you what we do here first, and then I'll explain everything, promise. So first of all, we'll need 4 new constants, one for the base CardRewards, which is 3, and then we have 3 weights, which are floats, right? One for the common, one for the uncommon, and one for the rare cards. Then, beside these constants, we'll also have 4 export variables which are corresponding to those. So we have one for CardRewards, one for the common weight, one for the uncommon weight, and one for the rare weight. And we make sure that their value equals to those constants by default. And one last thing we'll do is we'll provide the reset weights method, which does one thing, like the name suggests, it resets those export variables to the values from those constants. So why do we need all this junk? Well, we want the card drafting to work very similar to how it works in Slay Spire. So we have our base rates in the constant values. Why do we have the card rewards? Well, because we have a relic in Slay Spire, which is called question card, which increases the amount of cards you can pick from in the drafting screen, right? It's 3 by default, but the relic can modify this to be 4. Also, there's a relic called Busted Crown, which decreases the number of cards which are visible when you draft new ones from 3 to 1. So in order for this number to be dynamic, what we do is we define a constant saying that, okay, this is the base rate, but we also have an export variable which can be modified from the outside if we need it to. And we have the same logic for the weights too, right? We have the base common weight, the base uncommon weight, and the base rare weight. And to make it easy to calculate with it, I use the total weight of 10 here, which means that we have a 3% chance of hitting a rare card, 60% of hitting a common card, and 37% for hitting an uncommon card by default. So why do we need the other variables here, the export variables? Because these are dynamic too by default. Why? Well, there's a very specific randomization feature in Slay the Spire when you draft cards. See, if you don't hit a rare or an uncommon card, those weights or those percentages start to increase when you don't hit them, right? For example, if I see 3 common cards in a card reward, then I get a better chance next time of hitting an uncommon or a rare card because we increase the weights of those. So these change dynamically and they reset whenever you can draft a rare card, for example. And we also can reset this on different acts if you have that in your game. So by using constants for the base values and using a separate export variable, which can be modified, we create a very flexible system which can be modified based on the interactions in the game. Cool, so that's all we need from the RunStats. It's pretty much set in stone now, so we can save this with Ctrl+S. And we have everything ready to go to start creating the BattleRewards screen, which is pretty exciting because this is the first real screen we do besides the battle we already have, right? So let's get started with that one. With all the preparation out of the way, we can finally start to build our BattleRewards scene. And we already have a placeholder for that, so why don't we just press Ctrl+Shift-O, search for BattleReward, open the tscn file, go back to 2D view, and make this something less ugly, right? So first things first, select the BattleReward node, the root node, click on this plus sign to add a new child, and we'll add a new texture rect. This will be the background. So we can just sort of drag this up here and rename this to background. Yeah, and for the texture, we can load our background image we have, this one, and we can set the anchor preset to full rect, change the expand mode to ignore size, and the stretch mode to keep aspect centered to make sure that it always looks like this. And we can rename this color rect by double clicking on it and calling it background dimmer, for example. And we can click on the color to make sure that it's a more opaque black, something like this maybe. And then we have this VBox container, which is fine, but we need to change the contents a bit, right? So for the label, we can click on the label and we can create a new label settings resource to make it a bit bigger. But if we click on this and go to font, I think 16 is too big. So why don't we change this to something like 12? Yeah, that looks better. And we can double click and rename this button to back button to make sure that we know what this button is for. And we can also change the text from go back to something like continue. And we can change it so it's not as wide as the container itself, because this container will become a lot wider in a second. So if we scroll all the way down here, we can set the minimum size to something like 50 by 14. And under container sizing, we can make sure that horizontally it doesn't fill the whole space, but rather shrinks to the center. It's just a bit smaller for now, but later on you'll see that this whole VBox container will be a lot wider, right? And between these two nodes, we need a container for the contents of this rewards screen. So select the VBox container, adding a child node with this plus icon or Ctrl+A. And this time we'll use a panel container node. And we can sort of move this between those two by dragging and dropping it to make sure that it's in the middle. And then we can do something like go to layout and set the minimum size on the Y to something like 80. Yep, that looks all right. And then the X, something like 110. That looks perfect, but we don't need this button or card look for this one. it can be just a pitch black box, right? So what we do is we go to theme overrides and styles and assign a new panel to this as a theme override, and we'll use a style box flat. And you can see that it becomes this gray thing. And if we click on this, we can change the background color to a black, and we can make it semi-transparent, maybe 50% transparent here, which is 128. And it already looks a lot better, right? So within this panel, we'll have other stuff. But before that, we can rename this, right? Instead of panel container, we can call this reward container. And within this container, to make sure that we have a nice little margin, we'll add a new margin container. So I'm pressing Ctrl A to add a new child node, search for margin container. And under theme overrides and constants, we can set the margins on all sides, which in this case will be 5. It looks like we did nothing, but if we add a new child node to this margin container, you will see the margins applied. So what we do is with this margin container selected, we add one less child node here with the plus sign or Ctrl A and search for VBox container. And you can see how it looks like, right? We have this nice little 5 pixel wide margin on all sides. And we can double click and rename this to rewards. And make sure to right click on this and access it as a scene unique name because it's kind of deep down in the hierarchy, right? And we need to access it in the BattleRewards script at the very top. And no longer how we decide to move around the UI, we can still have access to it if it's scene unique. And within this VBox container, we'll have some buttons which the player can click on to collect rewards, right? And for this, we need to create a separate scene so we can reuse those buttons. So first of all, save all the changes we made here by pressing Ctrl S, and then we can click on the plus sign to create a new scene. And in this new scene, we'll use another node as a root node and search for button. Double click and rename this to RewardButton. Zoom in a bit to see what's going on better. And we'll do a bunch of sort of custom content within this button. Even though we only want to display an icon and a text, which you can definitely do with the button node itself. You can see that we have those properties here, but you have way more control over the appearance if you do it yourself with a custom node structure. So this is what we're opting for here. First of all, we'll add a new child with the plus button on Ctrl A and search for margin container to make sure that we have a nice margin around the edges. And go to theme overrides, constants, and we'll set a margin of 4 pixels at the sides and 2 pixels at the top and the bottom, like so. And before we add any other nodes, we could change the size of the reward button because this is really weird. So let's go back to our reward button, go to layout and transform and set the size to something more reasonable, like maybe 75 by 14, right? This is how our button will look like roughly. And under the margin container, we need to make sure to set its anchor preset to full rect, so it covers the whole rectangle of its parent. And then we can add a new child node, this time an HBox container for the icon and the text, and you can see those margins in action. And for that HBox container, we'll again add 2 new child nodes, a texture rect for the icon, and we can select it again and add a label for the text. Nice. So we can double click and rename this to something like custom icon and rename the label to something like custom text. And we need to make sure that those are accessible as scene unique. So if we move them around, we can still reference them in code. So right click this, access a scene unique name, and we can set some placeholder values to see how this will look like. So for the icon, we can load a texture, for example, our gold.png, and you can see that it's definitely bigger than it needs to be. So we can go under layout and set the custom minimum size to something like 10 by 10, and we can set the expand mode to ignore size and the scale to keep aspect centered. Cool. So it looks much better already. And for the text, we can type in something like 99 gold. Right? And what we can do is we can center it on the vertical axis and make sure that under layout and container sizing, we fill all the vertical space. And I don't really like that separation between the icon and the text by default. So if we go to the HBox container, theme overrides, constants, we can change that separation to something like 2 pixels maybe. Yeah, it looks much better in my opinion. And that's all we need for this reward button from the editor. So we can save this with Ctrl S under the UI folder, rewardbutton.tscn is fine. And we can attach a script to this to make sure that we can interact with it. Click on the attach script button. Make sure we use the object empty template so we don't have auto-generated code, and press create to open up the script. And here we need to connect the pressed signal of this reward button. So make sure that this root node is selected, go to node, double click the pressed signal and connect it to this script here. And this script is pretty straightforward again. We'll provide a custom class name, which we'll call RewardButton. And we'll have two export variables, a texture for the icon and a string for the text. So we can set this from the BattleReward script later on. And what we do is we also provide two already variable references to our custom icon and custom text nodes. And we also need to implement those two setter functions, which will work pretty similarly, actually. First, we'll change the property. So the reward icon becomes the new icon. And then we'll check if the node is ready in the scene tree or not, because if it's not, we need to wait for it because of the export variable. And then we can set the custom icon nodes texture property to this new icon we have. And we do virtually the same with the text, right? So we have the setter function, change the value, check if the node is ready or not. If it's not, we wait for it. And then we set the custom text nodes text property to this new text we have. And let's not forget that we connected the button's pressed signal to this script. And what we can do is we can delete this object after clicking on it. Why? Because if you think about the flow of this whole thing, we have this little button saying 99 gold, right? We click on the button, we'll connect the pressed signal of this button to our BattleReward to make sure that it adds the appropriate amount of gold. And at the same time, we can sort of command the button itself that, hey, you should delete yourself at the end of the frame. Because if we click on it, the BattleReward will do its thing, which is giving the player the appropriate award. And after that, we don't really need that button anymore, so we can delete it. And that's all there is to it, to this reward button scene and class. So we can save this with Control S. And we can actually go back to the BattleRewards scene and instantiate some buttons so we'll be able to test them. So go back to 2D view, switch over to BattleReward. And under this rewards VBucks container here, we can click on the instantiate child scene button or press Ctrl+Shift+A and search for RewardButton.tscn. After adding it, duplicate it one more time. And you can see that we have a problem here, right? Because those buttons are not looking properly. Why is that? Well, because we haven't set minimum Y size to those buttons. So we can very quickly fix that by going back to the reward button, clicking on it, go back to the inspector, and set the custom minimum Y to something like 14.2. And if we save this with Control S and go back, it should be looking much, much better now. Perfect. So we can double click on one of them and rename it to GoldReward. And click on the other one and rename it to CardReward. But in order to test this or test how they look like, we can change up those values. So for the GoldReward, we can load this same texture, this gold.png, and set the text to something like 127 gold, maybe. And for the CardReward, we can load another texture, for example, this diamond from the card rarities, and say something like add new card, right? And if we save this with Control S and run the scene, cool, we have those little buttons, and if we click on them, nothing happens, but they delete themselves. Perfect. So the buttons are kind of working, right? Now we actually need to make changes to our BattleReward script, which is sort of just a placeholder for now. So click on the BattleRewards script icon here to open it up. And we can actually fix this method here, because if you remember, we renamed our button to back button here. So what we can do is we can go to node, right click on this connection, disconnect it and connect it again. And it will say on back button pressed. And I like this better because it reflects the node's name properly. So our code stays organized. And what we can do is we can sort of just cut this piece of code and paste it here, and we can get rid of the old code, right? The connection was still there, so there's no need to do this, by the way, but I just like keeping things tidy and organized. And the callback function reflects the node's name properly now. So I split adding GoldRewards and CardRewards into two different tasks here because they are quite different from each other. And adding GoldRewards is a much easier task to do. So why don't we start with that? So what we do first is we create a custom class name now called BattleReward. And then we'll have a custom enum called type for the different kind of rewards we can have. We'll have gold reward, new card reward, and relic rewards. Relics will be implemented much later down the line, but we can still add it as an enumeration. Hey, editing Adam here. I made a pretty big mistake in the recording. See, I have the whole project finished before I recorded these videos, but sometimes I change the code just before recording because I think of a better solution. Here, the same thing happened, but I realized that I actually never used this enum in the new code, and for some reason I left it there. So please, if you're following along, delete this enum from BattleReward.gd because we won't be using it anywhere. Sorry for the inconvenience. Then we'll have a constant to our reward button scene so we can instantiate it. Then we'll have 4 constants for the different types of rewards. We'll preload the icons and we'll have text for the gold and the card rewards for now, but we'll add relics later on again. You can see that for the gold's text, we have a placeholder format string with the %s sign, so we can always insert the current number we need for that particular gold reward button. Then we'll have an export variable for the RunStats, and we'll provide this dependency from the run scene and the run script, right? Because he is the brain of the whole operation. If you remember, the run is responsible for providing all the different dependencies for all the different screens. And this screen in particular needs a RunStats resource, which we'll provide from there. And we'll also have an onReady variable reference to our rewards VBucks container because this is where we want to instantiate our reward buttons. Then in the ready callback, what we do is we get rid of all the placeholder nodes we have, right? We need to delete them under the rewards VBucks container because we have 2 placeholders. If you remember, we just tested them earlier. Then these 2 lines are for testing purposes only. So we can test this BattleRewards scene separately and we don't need to do it from the run. So what we do is we create a new RunStats resource and connect an anonymous function to the gold changed signal, and we print out the current gold. So we can test if the gold actually increments after clicking on the gold reward button, right? Then we'll provide a public function called addGoldReward, which takes an amount as an integer parameter. And what it does is it instantiates a reward button, sets the icon and the text accordingly, and connects the pressed signal to our own gold reward taken method, which we are yet to implement. And by the way, you can see that little placeholder %s in the string in action here. Why? Because take a look at this line of code here. We say that the reward button's reward text property should be equal to our gold text constant, with actually inserting the amount as the first placeholder value here, right? So instead of this %s, we'll see 125 here or something like that. So this is what makes it flexible. And finally, let's not forget that we need to add this child, right, to our reward VBucks container. And I use call deferred here to make sure that this happens at the end of the frame. And finally, we also need to create this onGold reward taken method. And what we do is we take the amount and first of all check if the RunStats resource is provided or not, because if it's not, we can return immediately. But if we do have a RunStats, only thing we need to do here is to increment the gold by the amount we have. And that's all there is to it. But in order to test this, we actually need to call this function, right? So we have a button we can click on. Because now if I run this BattleReward scene, you can see that those 2 placeholder children indeed get deleted, but we don't have anything to click on, so we can test this. So to do so, in the ready callback, we can just say add gold reward and provide an amount like 77, for example. And if we save the script and run the scene again, you can immediately see that we have this interactable little button here, and we should be able to click on it. And you can see that the button disappears and we have this little print message saying that our gold is 147. And that checks out because if you think about it, our starting gold when we create a new RunStats resource is 70 and we added 77 to that, right? So 147 is absolutely correct. Cool, so everything works fine here. And that's the easy part done, right? We have the gold reward. We can leave that little testing code here because we'll also have some test code for the CardRewards as well. So for now, this can stay. Now let's move on to the bigger fish and actually do the card rewards next. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. If you remember from the architecture overview in this video, we'll need a custom card pile from which we can pick cards to draft, right? Because we want to exclude the basic strike and defend cards, so we want to have a separate array for providing basically a pool of cards which you can get rewards from. And to do so, we need to go back to 2D view, scroll all the way up, collapse these custom resources here, expand the characters folder, and under the warrior, we can right-click the warrior folder and create a new resource. And this one will be a card pile, right? And we can call this warrior draftable cards or something like that. And we can double-click this resource, but you can see that we see nothing here. It's because we're in the node tab currently. But if we go back to the inspector tab, we have an array of cards here. And we can set the size to 9, right? Because we need at least 3 common cards, 3 uncommon cards, and 3 rare cards we can draft. Why do we need at least 3? Well, because if you think about it, for example, in Slay the Spire, when you defeat a boss, all of your card rewards are rare, right? And we need at least 3, ideally even more, but for demonstration purposes, 3 is perfectly fine, because the game would crash if we didn't have at least 3 rare cards which we can pick from, right? So what I'll do here to save some time, instead of creating a bunch of unique cards, which you should definitely do for your own game, I'll just add the same cards 3 times to make sure that we can draft them. But ideally, you would create a bunch of unique cards, right? Because this is what makes deck builders fun and interesting. But for now, what we'll do is we'll expand the cards folder, and we can use True Strength as a rare card. And it's easier to do if you just drag it from here upwards and maybe make it a bit wider so we can see a lot better. We have the Big Slam as an uncommon card, right? And just to make it a bit more interesting and to see if the system works actually fine, I'll use all of the common cards here. So you can actually draft strike and defend cards in this case, but if you want to, you could exclude them from this array, right? Like so. So we have 3 common cards here, 3 uncommon, and 3 rare. You know what, maybe we could exclude the basic attack to make sure that the exclusion system is working too. So why don't we just use the block twice? And these will be considered different cards, by the way, in our system, right? All of those. And that's important because in theory, you couldn't hit the same card twice in the same reward, right? So for example, in Slay the Spire, you wouldn't see 2 echo forms next to each other with the defect. And we'll take care of that too, but here, because I don't have enough cards to test the system, we just use the same one over and over again. So these are considered to be different, even though the cards are the same, right? But if you had 9 different cards, we will implement that each offer should be a unique one, if that makes sense. Okay, so now we have this draftable cards resource, but we don't use it anywhere, right? So the next thing to do is to go back to script, press Ctrl-Alt-O, and search for character stats, because we need to change the stats a bit next. And just one tiny little change here, really. Under the gameplay data export group, we'll have a new export variable, which we'll call draftable cards, and it will be a card pile, just like the starting deck is. So we can save this with Ctrl-S, but let's not forget that we actually need to assign this resource to the warrior itself. So go back to 2D view, double-click warrior.tres, and we have this new draftable cards property here, which is empty for now. So if we scroll down, we can drag and drop draftable cards here to make sure that we have this information available when we need it. And now we have everything set up for the card rewards. So we can save this with Ctrl-S. So the next thing we'll be doing is the UI interface for picking a card reward. And again, we have 2 options here. We can either do this here in the BattleRewards scene, but I argue that it's not the best idea. Why? Well, because picking a card from a card reward screen can be reusable in the project. When and how? If you think about Slay the Spire, you have some relics or potions which provide kind of the same functionality, but it's temporary, right? So for example, if I drink an attack potion in the game, I get offered 3 different cards to pick from, and they will cost 0 in that turn. And temporarily, for one fight or battle, this card will remain in my discard or draw pile, right? But it doesn't get added to my deck. But picking a card out of 3 remains the same. It's the same as taking this card reward here. Again, it's always a good idea to take a step back and think about what you need to do here. And ask yourself, will I reuse this anywhere else in the game? Are there systems which are reliant on this functionality? If the answer is yes, then it's probably a good idea to sort of abstract it out to its own scene so we can reuse it later. We won't be reusing it in this project, but I still think it's a good idea to do it because I know that in the game there are use cases where you actually can draft or pick one of 3 cards. So we'll go with that solution. And to do this, we'll create a new scene. So click on this plus sign, and our root node will be a color rect. So click on other node and search for color rect. We can double click and rename this to CardRewards. Make sure to set the anchor preset to full rect so it covers the whole screen, and we can zoom in also. Set the color to like a dark black, which is semi-transparent, something like this. And under that, we can add a new child with the plus sign here. Search for VBox container. Under that VBox container, we'll add a new child again, which will be an HBox container. And this is where we'll have our cards next to each other, right? So we can instantiate some CardMenuUIs to test how this looks like. And we can duplicate this by pressing Ctrl D 2 times. Cool. Under this VBox container, we'll also need a button in order to skip the cards if we don't want to add any of them. So click on the plus sign, add a new button here. And also when we actually click on those cards, we want to read the tooltips before deciding if we take them or not, right? So under CardRewards, the root node, you can click on Instantiate Child Scene and search for Card Tooltip Popup.tscn, which we kind of already have and can reuse for this purpose. Right, we need to make some changes to that, and I'll get back to that in a second, but first of all, let's set up what we have here. So the first thing we'll do is we hide this Card Tooltip pop-up to see what's going on better, and click on the VBox container and anchor this to the center of the screen by clicking on this anchor preset and selecting center. Right, already looks a lot better. We can also set the separation between the button and the cards, but to do so, let's just first edit the button so it looks proper, right? So click on the button. Under text, we can use something like skip. And let me just make this a bit more narrow so we can see the scene better. And under layout and container sizing, make sure that in the horizontal axis, we set this to shrink center. And we can set a proper minimum size to make sure that it's not that small. Something like 50 by 14 will work probably. Yeah, it looks better. And now we can set the separation between those cards and the button itself by selecting the VBox container, go to theme, overrides, constants, and set the separation to something like 10 pixels. Yeah, that looks perfect. And we can also set a separation between those cards themselves because they are pretty close to each other by clicking on the HBox container. Go to theme, overrides, constants, and setting the separation to maybe 10 again. Yeah, feel free to choose anything you like. I'm not a UI expert by any means. But what we also need to do is to rename some nodes. So double click this one and rename it to cards. Double click on the button and rename it to skip card reward or something like that. And make sure that this is scene unique by right clicking on it, and the same with the card right click, access unique name. Cool. We still have something to do, however, because the card tooltip pop-up, if we again make it visible, you can see that the background is black here. But in the demo, I've used the purplish color here. And we can't do that because it's a set value in the card tooltip pop-up, right? So we need to make a slight adjustment to this scene so we can reuse it here with a different color background. But before we do that, let's not forget to save this scene first by pressing Ctrl S. Going back to the root folder, go to scenes, UI, and CardRewards.tscn is fine. Press save. So here we could redo this whole card tooltip pop-up functionality because if you think about it, not just the color that's different, but we'll also need the button here called take. So we can actually pick one of those 3 cards here. You can sort of get ahead of yourself and start coding like crazy, which is what I did when I was doing this project. But then I stopped for a second and thought about, hey, but the functionality is kind of the same, right? We're just changing a background color and adding a button on top of the whole card tooltip pop-up, which can still function on its own, right? So here actually redoing it is violating the dry principle, which is don't repeat yourself. And I started repeating myself and sort of caught myself in the process because it's so quick and easy to kind of just copy stuff over and do it in a slightly different way. But why would we, right? It's much easier to change this. So we need to introduce a very small change to this card tooltip pop-up, which is actually exporting this background color variable so we can change it however we like to. And to do so, we just need to click on the script icon here next to the card tooltip pop-up. And let's see how we can change this. What we do is we provide a new export variable called background color of type color, and we assign the current color of the card tooltip pop-up, which is the default one we'll provide, right? So all the card tooltip pop-ups we are already using in the game won't be changed by this because the default value will be the same color. We also need to provide an onReady variable reference to the color rect itself, which is called background in the scene tree. And one last piece of code here is in the ready callback, which is just actually changing that color rect's color property to this export variable we have. And that's all the changes we need to make it reusable instead of almost redoing the same functionality, which is a bunch of logic, showing, hiding the tooltip and all that stuff. We don't need to redo that, right? So we can save this with Control S. And now if we go back to 2D view and click on this card tooltip pop-up again, we can actually change the color here. So if we click on this background color, we can set it to something completely different. Like for example, I've used this sort of purplish, pinkish color here. You won't see the change right away, but if we run the scene again, you can see that it's updated, right? So we made it reusable, but we're still missing the button here. So what we do is we close this for now. And under the card tooltip pop-up, which is an instantiated scene now, we can still add a new child node, right? So click on the plus sign, search for button and add a new button node here. Double click and rename this to take button. Right click and make it scene unique. And we can anchor it to the center bottom of the screen and change the text to something like take. And let's change the size a bit because this looks weird as usual. So go to layout and under transform, we can set the size to something like 50 by 14, for example. And you can see that it messes up the anchoring, so we can anchor this again. And I don't really like that it's all the way up to the bottom edge of the screen, so I go into move mode by pressing W and shift click and drag this somewhere around here. And you can see that it's completely independent of the card tooltip pop-up, right? And that's not a problem because the card tooltip's functionality is to show the description and the image of the card. It doesn't care that it has a take button here as a child, but the CardRewards itself will care because this is what makes it interactable. But it's still useful to instantiate it under the card tooltip pop-up because if we hide that one, the button gets hidden too. So it's perfect for us. And it can stay hidden for now. And finally, we can add the code to this to make sure we can actually see and pick cards in this CardRewards screen. And to do so, click on the root node, the CardRewards node, click on attach script, use the object empty instead of the node default, and CardRewards.gd is fine. Press create, and let's see how we can do this. So this is the class that will handle selecting or skipping CardRewards. How do we do that? First of all, we'll provide a custom class name called CardRewards. Then we'll have a signal called CardReward selected, which has a card resource as a parameter that indicates which card we picked. Then we'll have a constant referencing or loading the CardMenuUI scene so we can actually see those cards. And we'll have an export variable called rewards, which is an array of cards. So this is how we know what we need to display. And this is a dependency. It comes from the outside world because the BattleReward class itself will generate those array of cards for us. And it also has a setter function to make sure that everything updates when we change this array. We also have 4 onReady variable references, one to the cards container so we can instantiate all the CardMenuUI scenes we need, one for the skip button, one for the tooltip pop-up, and one for the take button. Then we also have a custom variable where we store the selected card. In the ready callback, we clear all the rewards so we can get rid of all the placeholder scenes we have here. And then we connect the take button's pressed signal to an anonymous function, which does three things for now. Emits the signal, the card reward selected signal, and passes the selected card variable as a parameter. So this is where we will store which card was selected. We'll also use a debug print message just to check if this works or not before hooking it up, and also delete the whole thing, because when we pick the card, we can delete this card rewards screen. In a very similar fashion, we need to connect the skip button's pressed signal, and we do kind of the same with one little difference here. We emit the same signal, but this time we're pressing null as a parameter, indicating that we haven't selected any of those cards. We'll also need to override the input callback. This is because when we press escape, which is the UI cancel event, we need to call the card tooltip popups hide tooltip method, so we can close it with ask. Next, let's define that clear rewards method, which will be pretty simple. What we do is we iterate through all the children in the card's HBox container, and we delete those cards with Q3, and we also hide the card tooltip popup. And finally, we set the selected card to null, because if we've cleared the rewards, there's surely no card to be selected, right? Then we'll have a show tooltip method, which will connect to the clicked signal of the CardMenuUI. So when we request a tooltip, this is the method we call. So here, why don't we just connect it to the card tooltip popups show tooltip, right? Well, for one reason really, is because when we actually click on a card, we want to make it the currently selected card as well. So we store that card in the selected card variable, and then we can call the card tooltip popups show tooltip method to make sure that we see the description and the take button and all. And then last but not least, we need to provide the setter function for the array of cards, the reward property here. And what we do first is we set the array to this new value. And then we need to make sure that the node is ready in the scene tree, because again, setting export variables can happen sooner before the scene tree actually is loaded and every node is ready. Then we clear all the rewards we currently had because we have a new array of cards, so we need new ones anyway. So we clear up everything before. Then we iterate through all the cards we have in that array, instantiate a new CardMenuUI scene, add it as a child to the HBox container, set its card property to the current card we're on, and connect the tooltip requested signal to this show tooltip method we have. I know this one's a bit longer, but hopefully you were able to follow my chain of thoughts here. That's all there is to it. So let's save this with Control S. And if we scroll back all the way up, we have these print statements here. So we should be able to test it just by going back to 2D view and setting that rewards export variable to something. So we can change the size to 3 and add 3 little cards here, the true strength. Then we can add the big slam and maybe a slash like so. And if we go ahead and run this scene now, we should be able to test it. And indeed, we have those 3 cards here available. If I click on one of them, we have this card tooltip pop-up and the take button shows up. We can close this, right? And if I click on the blue one and say take, you can see that it deletes itself and says drafted warrior big slam. Perfect. Let's test the skip button as well. So if we run it again, click on skip, it deletes itself again. And if we take a look at the debug window here, it says skipped card reward. Perfect. So this works absolutely fine here, but we still need to hook that up in the BattleRewards scene, right? So this is what we'll do next. So to hook this up in the BattleRewards scene, we need to go to that scene and change the script we have. So click on the script icon here, and let's see how we can hook up this whole card reward system and start generating the cards and putting all the puzzle pieces together, basically. Okay, so this is the hardest bit of coding we'll do in this video, so I try my best to explain everything as clear as possible here, okay? So let's get started. So first of all, we'll need a constant to our CardRewards scene, which we just finished earlier. And then beside the RunStats dependency, we also need a character stats resource as a dependency. Why? If you remember the architecture overview from the beginning of the video, you might remember that we need this draftable cards array in order to generate eligible cards for drafting, right? Then we'll also need a bunch of new variables here for the weight calculations, because this will be a weight-based system when we generate just like it was with the enemy actions. So we'll have one variable for the total weight, and we also have a dictionary of rarity weights, where the keys are the card rarities, the common, the uncommon, and the rare rarity, and the values are the accumulated weights of those rarities. Then in the ready callback, for only testing purposes, for the character stats, for now we'll just load the warriors and create a new instance of it so we can test it here without starting a new run. And we'll also add 2 new card rewards to see if they work or not, but we're yet to implement this method. So in this add card reward method, what we'll do is we'll instantiate a new reward button and set the text and the icon accordingly, connect the pressed signal to this show card rewards method, which will be a very big, robust method for generating all the different rewards. And after connecting the signal to that method, let's not forget to actually add it as a child to our rewards VBucks container. So this is the biggest one here. How do we show the card rewards? First of all, let's start with a safety check to make sure that we actually have RunStats and character stats available. If any of those two are missing, we can't really do that because we don't have access to the current weights, and we also don't have access to an array of draftable cards. But if we do, we need to create a new card rewards scene, which we loaded as a constant and added as a child. And if you remember, in the card rewards scene, we have a signal called card reward selected, which we can connect to, and we'll provide our own callback function here later on. And then we can really start to have fun with this code. First of all, we'll have 2 arrays. One which we call card reward array. This will be the final one where we have our 3 cards at the end of this whole algorithm. Then we have another array of cards, which we call available cards, and it's a duplicate of the character stats' draftable cards array, right? And what we do here is we start a loop which repeats for the amount of card rewards we currently have according to our RunStats. Remember, this is by default 3, but we made it flexible so it can be modified by relics, for example. And what we need to do first is we need to set up the card chances. And why do we do this for all the cards? Well, because if you remember the rules we have, each common card we roll for increases the chance of finding a rare one next. And that's true within the same 3 cards as well. So we sort of need to recalculate and redistribute our weights after every card roll. This is why we put it inside the loop. And then we actually roll for a number which will be a random float value between 0 and the total weight we can have. Then we loop through our card rarity weights dictionaries keys, which are rarities themselves, and we check if the roll matches the weight of that rarity or not. And if we found a match, it means 2 things basically. First of all, we need to modify the weights, right? Because, for example, if we found a rare card, it means that the rare weight should reset to its default value. And these are the changes we'll do in this modify weights method later on. And 2, what we also need to do here is to actually get a card, right, which matches that rarity. So if we rolled for the rare card again, then we need to pick a rare card randomly from all the available rare cards. And this is what we do here with this get random available card method, which we also need to define later on. Then what we can do is we can append this new picked card to our card reward array, which is the final result we'll have, and also erase it from the available cards. Why do we do that? Well, because if you remember, I said that you can't roll for an echo form twice within the same card reward, right? And this ensures this, because the array.erase method erases a specific value from the array. So technically, if we rolled for an echo form once, we delete it from the array to make sure that it couldn't reappear as a third card, for example, within the same card reward screen. And if we do have a match, we can break out from this loop because we already found the matching rarity to the current roll we have. And finally, we're almost done with this function. What we do is we set the card reward scenes rewards export property to this new array we just populated, right? And then we can actually show that card rewards screen. Let me go back to the card rewards script for a second. If you scroll all the way up, you remember this is the export variable we use to display those cards we have. And this is what we set here, right? Because we populated this array in this long method we have. Whew, that's a big one. Now, all we need to do is sort of implement all those missing methods and we should be good to go. And all those methods will be much simpler compared to this one, I promise. So let's start with the setup card chances one. Here what we do is we sort of just assign the values to the variables we have. You can see all the code here, and if you remember, let me scroll all the way up here. We have these variables here, right? We have a total weight, and we have a dictionary where the keys are the rarities and the values are the accumulated weights. And this is where we set it. So what we do is for the total weight, we just need to add together all the current weights we have in our RunStats resource. And we do kind of the same for all of these. So we start with the common, which only has the common weight. The uncommon will have the common and the uncommon combined because this is an accumulated weight, if you remember. And the rare will be basically equal to the whole thing. If you forgot about how this random weighted distribution works, I recommend going back to that video from season 1 because we talked about this topic in a lot more detail than I do now. But we do the same thing here. For the modify weights method, we do two things. If we rolled a rare rarity, that means we need to reset it. So what we do is we set the RunStats current rare weight property to the RunStats base rare weight, which is the constant where we start from, right? Otherwise, it means that we didn't roll a rare card, but we rolled either a common or an uncommon one, which means that the rare weight should increase to increase our chances of rolling a rare card next. So what we do is we take the rare weight and increase it by 0.3, but we make sure to clamp it between two values. So it can be lower than the base rare weight, but it also can be bigger than 5 because that would mean that it's like almost 50% chance that you roll a rare card. We can go above that. This modify weights method here is a lot simpler actually than the Slate Aspire version of this. It's a lot more complex in Slate Aspire. This whole rare thing starts from a negative value and it can go all the way up and there are a bunch of different rules applied. So I sort of just simplified it here. If we roll the rare, we reset it. But if we didn't, then we increase it by some value and we kept it at 5. For the purposes of this tutorial and course, it actually does the job pretty well. Then we need this get random available card method, which is pretty simple. We take all the available cards we have and call this filter method. And what this filter does is it sort of evaluates a Boolean expression and only keeps the values in the array which returned true for that expression. So we do an anonymous function here and we check if the card rarity is equal to the rarity we rolled for. This way we can filter out all the cards which doesn't match the rarity we rolled, and then we return a random value from the remaining cards. And I believe the final thing we need to do here is to actually implement this on CardRewards take-in method so the battle reward itself knows what to do when you actually take a card. And first we can provide a safety check because if it doesn't have character stats, it means that we don't have a deck we can add this card to. Or if the card itself is null, it means that we skipped the card reward. So if either of those happens, it means that we shouldn't do anything so we can return from this function immediately. But if we did take a card and we have access to a character stats resource, it means that we should add that card to the deck of that character. And here I also included two print statements so we can check if those cards or this card is actually added to the deck or not. Whew, that should be it. Okay, so make sure to save this with Control S. And we should be able to test this. We have those print statements here, and if we go back to the ready function, we have character stats, we have RunStats, and we add 3 kinds of rewards here. So let's actually test this by running the battle reward scene. And indeed, we have the 3 buttons. Let me make this output console a lot smaller because it's way too big. And you can see that if I click on the gold, we add that gold to our current value, which is 70 plus 77. And also we can add new cards here. And if I click on one, cool, we rolled for 2 uncommon and 1 common card here. And I can decide to take one of those or skip it. And for this one, I'll take the 3rd one. And you can see when I take it, we have this long debug statement here, and my deck before has 12 cards, and the true strength is the final one. But the deck after should have 13 cards, and added a warrior big slam at the end, and we also have the print message saying that a drafted warrior big slam. Cool. And if I click on it again, you can see that I got a rare card offered here. but we can ignore that and test if the skip is working or not. So if I click on skip, I don't see the long message because if you remember, this callback function says that if we decided to skip and we don't have an actual card, we can return from this function immediately, so these print statements never get executed. And indeed, it doesn't. So what we can see is we have this little debug message here that we skipped the card reward. Cool. So all of the systems we designed in this video are in place and working now. One final thing to do is to hook this battle reward stuff in the run scene. So connect it to the brain, to the flow of the whole game or project. But before we do that, we have a bunch of print statements we can finally get rid of, right? So we have those two here. We don't need those. And if we go back to ready, we don't need those pieces of code which we use for testing either. So we can get rid of all these. Right, that looks fine. And we can go back to the CardRewards.gd as well. And here we have these print statements, which we no longer need. Okay, so everything's working fine now. We can save this with Control S and go for one final ride to actually hook this up in the run scene. But hooking all this up in the run is not that difficult actually. So all we need to do is press Ctrl-Alt-O and search for run.gd. And here we need to change a couple of things. First, we need to modify this change view method. What does this do? If you remember, we take a pack scene and instantiate it and add it under the current view node, sort of establishing that this is the screen you're watching now. This is what we use to switch between battle or campfire or map or whatever. So the problem now is that when we instantiate our battle reward, for example, we use the scene.instantiate, which is fine, but we need to set and inject our dependencies, right? If you remember the architecture overview, it needs to have access to the RunStats and the character stats resources. These dependencies are not the same for all the contexts, right? The campfire doesn't need the same thing as the shop does, or the battle doesn't need the same resources as the battle reward does. So we can't sort of generalize it and do it here because all those views have their own needs. But what we can do instead is say that this change view is no longer a void method, but it returns that new node. And we can add a new line of code here saying that return new view. So whenever we change the view from now, we can decide that if we want to store that reference to that new view, we can store it and set all the dependencies we want. So that's one thing. And another one is to actually don't just use this change view.bind here because we want to do other stuff than just changing the view, right? Like injecting those dependencies. So events.battle1 is our first victim of this change or this refactoring. So what we do is we say that we connect this to a new callback function, which we'll call onBattle1, which is not implemented yet. So we'll get this error message, but this is the last thing we need to do, actually creating this method. So this method will be pretty simple. First of all, we'll call this new change view method we have and pass the battle reward scene, same as before, right? But we cast it to a battle reward with the S keyword and actually store it as a variable to make sure that after changing the view, we can inject those dependencies. So we'll set the run stats to the run's own stats resource, and we'll set the character stats to the character resource of the run. And then, in order to test this, we can provide temporary code here saying that we add a gold reward of 77 and add a card reward after each battle. Why is this temporary? Well, because later on when we'll generate the map and create different kind of encounters, this data of what reward you can get out of a battle will be actually stored in a different data container, and we can just sort of reference it here. But for now, it's perfectly fine to say that every win is rewarded with 77 gold and a new card reward. So that's all there is to it. All that's left to do is to actually test this whole thing together we just did. So save this with Control S, select our run scene here, and make sure that we run this scene with F6 or that button. And in theory, we should be able to go to a battle, actually win that battle somehow. And after winning, we have this little victorious screen here. Click on awesome. And see, we immediately transition into the rewards because we already have that hooked up in the run scene and class itself. And now it's not just a placeholder scene anymore. We have our new little window here and we can click on the gold. The gold UI gets updated and we can add a new card. I don't know, take this blue one. And you can see that the deck gets updated as well. And if I click on it, you can see that I have my 13th card here. And click on it, view it. And everything works perfectly fine. If I click on continue, we go back to the map and we're done. That's all for the battle rewards. One minor thing I want to do here is actually going back to the battle reward scene and going back to 2D view and move the whole thing a bit down because the top bar kind of overlaps with it now. So if we select this V-Bucks container here, I go to move mode by pressing W and shift drag this down a bit like so. And if we test the run again, this time I won't be playing a whole battle, but I just go to this reward scene with the debug button and you can see that the title no longer overlaps this top bar here and I like this one a bit better. Cool. So thank you all for watching and I'll see you in the next one. Bye bye.